All right, so who here has heard about Webpack? I hope so. That's why you're here, right? Okay. So yes, my name is Sean Larkin. I'm a program manager for Microsoft and their web platform. And I work on Edge Dev Tools. But aside from that, I'm one of the maintainers of Webpack. I kind of fall in line with the developer advocate kind of role. But then I've also done some work on the Angular core team. Who here uses Angular? Angular, okay. Yes, nothing wrong with that. There isn't. And just a general kind of evangelist for open source sustainability. A little bit about myself. So I'm kind of a former tech support rep gone rogue. I got tired of not being able to solve people's problems. And so I kind of learned AppleScript. Whoever has written an AppleScript before? Yeah, like that was my first programming language. And then I did a little bit of Objective-C, Swift, JavaScript. And I do like woodworking, chicken farming, Internet of Things. So yes, like I said, sustainable open source practices. I've been trying to be involved with encouraging others to be involved with open source. And how can you grow your organization? How can you grow your community? How can you make it rich and thriving? So you can find me at the Larkin. So feel free, you can take a look and see me at any of these places online.
Yeah, hi. My name is Tobias Koppers, and I'm the founder of Webpack and also maintainer, and also part of the core team. And yeah, oh, too fast.
Go ahead.
Yeah, currently I'm doing full-time open source Webpack development. And yeah, next.
Yeah, you just tell me when, I'll do it. No, it won't work from this far. There we go. Cool.
My background is a little bit weird for a JavaScript developer. I started with C#, C++, C development, and did JavaScript as a hobby. And yeah, so I came to make Webpack. But I never done a real web application so far.
Never made a real web application. What?
Yeah, you also find me on GitHub and on Twitter because the SOQUA was already given.
Yeah,
taken
somebody
away
took
on
it.
Twitter. So
that's right.
I added a W. It's cool.
Why not? Yeah, it's cool.
Okay.
So yes, we're going to talk about a lot of things today. And a lot of it is going to be about Webpack, of course. Hold on. So on a side note, Tobias, when you wrote Webpack, it was not for your thesis, right? It was for the web project that your thesis was for.
Yeah, I did a web project in my thesis, but it's a small one, a thesis one. Okay. And yeah, I felt the need of Webpack, a module bundler, and it started with a pull request to another project,
yes.
modules webmake, but it was rejected, the pull request, so because it was a complete rewrote of the library, and so I published it as under another name.
Modules Webpack. Yeah, or
yes,
Webpack.
and it was renamed to Webpack.
Yes.
So
it wasn't even for his thesis project. Just shedding some light there. So yes, but we're going to talk about not only how Webpack works under the hood. I'm going to kind of so who here has never actually configured their Webpack before? We love Create React App. We love everything that, we like being able to write code when we need to. There are some people out there who love configuring or, have very unique kind of scenarios, and that's why Webpack exists. So we're also going to talk about just the high level, understanding how Webpack works from the user interface, and then we're going to talk about how it works under the hood and what we have coming for you for Webpack 4. So, who knows what a JavaScript module is? Yeah, okay, cool, yep. Sure, why do we like them? Because they're reusable, they're encapsulated, organized for the most part. Unless you have a Redux and React, and then it's everything's spread out everywhere. They're convenient, but what do they look like? Well, you have CommonJS. If you're just familiar with it, just raise your hand when you see the module type that you've used before. CommonJS, yes. AMD, yeah. AMD plus CommonJS. Wow. I've never seen this before until I made this slide. And then we have TypeScript or ECMAScript module syntax. Pretty similar, pretty similar. Should I shake the dongle? So there we go. Excellent.
Luckily, we are in the issue-free stage.
Yeah, we're on the issue-free stage. Yeah. Yeah, submit an issue, okay, and we'll get back to you. So how do they work in the browser? Well, they don't really, or if they do, not very well or not very fast. Maybe soon. And every library is different. Like, wouldn't it, if you go and npm install or look at your package.json, every single library might ship a different format of these modules. And it's up to them. And this is just JavaScript that we're talking about. It's not even talking about other things like styles, assets, images, PNGs, etc. So wouldn't it be nice if it all just worked together seamlessly? So that's Webpack. That is what Webpack is. So you all know Webpack is a module bundler. But I like reinforcing the idea, what does this mean? It lets you write modules that work in the browser. That's simple. Was that probably the main premise, Tobias? You'd say like that was the point.
Yeah, this was the point, but also code splitting was my intention in writing Webpack.
That's right.
Because I did the pull request for code splitting. That's
right, from Modules Webmake. And if you wanted to know about that story, check out our README at the bottom of the README. So just going to blaze through kind of since most people understand how to use it. So we have our config. We have a CLI, which literally uses the Node API behind the scenes. And then we have the Node API itself. And so this is the core concepts. I'm just so that you can understand before we dive under the hood how it works kind of on top of the hood. So we have our entry point. Let's say given you have a module and it relies on, another component. And then that component probably relies on a couple more components. You're importing or requiring them, whatever syntax. But that one has a dependency. It's a common JS library, let's say. But wait, it's like Bootstrap or something else. They have style dependencies in one way or another. That is our entry. That is the entry point. When we talk about entry in Webpack, the root of that graph is what we're referring to. And so it is the first JavaScript in your project to kick off your application. So you can kind of see here, when you define your entry point, Webpack literally says, hey, okay, let's start at this file, we'll resolve it. And then we're going to trace through here and go through each of these pieces to make sure. So we're basically telling what to load for the browser. And it works with the output property, of course. So output, that's another core concept. So you can think about it exactly what its purpose is. By defining specific properties like a path and a file name, we're telling Webpack how to handle these files. So in this case, we've created a bundle, outputted to a folder. And there's way more properties that you can define in output, but that's the high-level idea. It's treatment of the dependency graph when it is created. So loaders. This is like one of my favorite parts, like good idea. Loaders were a great idea, Tobias. So not every dependency is going to just be JavaScript, but we want to explicitly tie them together. So loaders allow you to tell Webpack how to treat non-JavaScript after it's been resolved. So let's say you have a TypeScript file, or JavaScript that the syntax doesn't make sense, or it's newer, ES6, something that's not supported by our traditional parser. Or let's say it's CSS or style. So you can kind of imagine in that same diagram that we use that it is tracing through these dependencies, and before we add it to the graph, these functional transforms are converting this into a JavaScript module in some representation. And there's all sorts of flexibility behind it. We can filter through them, like how many know commonly, a good practice or something we see a lot in the React community is that you ignore your no modules or exclude them. Who has seen that before, probably? Good share of hands. Yep. So lots of different options to filter through, and it's incredibly flexible. So much that you can even chain it together. So let's say if you have something like less. Well, the traditional idea or foundation is that you want to have a loader that performs one operation. So one transform, and then you can chain them together. So if you have a less file, you'll see here, it converts it to a style.css, converts it to like an array in memory of that style. Isn't that pretty much what it is, like an array? And then we get this JavaScript module called inline that style into the browser with style tags. Best way to say it. But there's literally a million different options that are out there in our ecosystem. And this is my favorite part, because a loader is just a function that takes a source and returns a new source. It's so easy to create and publish and share and have this really rich ecosystem that we have for our project. So loaders tells Webpack how to interpret and translate files, especially that aren't JavaScript. And they kind of return compilations. They return new sources. So plugins. Who has ever written a custom plugin? Yes. Maybe this first 5 minutes is too boring for you. This is the anatomy of a plugin. So I like to define it as a class. Tobias always corrects me and says it's an instance. So it's just an object that has an apply method on the prototype chain. And so you can see here, this is the anatomy. And so what we have is that whenever this plugin is registered, Webpack will call apply plugins, and it will pass an instance of itself into this plugin so that hooks can be hooked into and then functionality performed. So in this case, this is super simple. Whenever the compiler is done or it has failed, we're literally going to write a dinging noise to the terminal. So now that you kind of understand, it looks like a class, it kind of has a constructor, how does it operate? So when you use it in your configuration, you're passing a new reference to it. And then that way, if you have options, let's say some of the more common chunks plugin, let's wiggle it, there we go, ship it. You can pass additional arguments, options, and features. Tobias on tech here, look at this.
I hold it.
But did you know that 80% of Webpack is made up of its own plugin system? Did you know that? Yeah. Oh my gosh. This was my response when I found this out for the first time.
A black screen?
Huh? Oh, you can, here. That was kind of, my mind was like, no way. Oh, that was a nice image, Tobias. I like that. Okay, no worries, no worries. So, we know that essentially plugins add additional functionality to Webpack's event lifecycle. And so it gives you the power to do anything that you ever wanted to. And so this kind of takes me to the next part of this talk, which is like the main guts. So who's feeling kind of comfortable so far? You're like, okay, Sean, tell me how it really works. How does it work under the hood? So the next part of this talk is we're going to now completely remember everything that I just told you, but don't try to tie it together with these concepts. So we're going to talk about how Webpack works under the hood as an architecture, as a system, as a bundler. But before we begin, we're going to talk about something called Tappable. Who here knows what Tappable is? Okay, cool. Somebody's writing some plugins. So Tappable is this 200-line library, 235, I think, to be exact. Not anymore, but it is the backbone of the Webpack plugin system. The whole architecture is based on this library. So, Sean, what does that even mean? So, Tappable allows you to mix in with an existing class, and then it magically is bestowed these awesome functions like apply plugins parallel, or apply plugins async, or apply plugins. And what that does is these are the events that get emitted that plugins are listening to. So who here has ever used Node's event emitter? Okay, Tappable is very, very similar. So you can see here that there is literally an event, and then in this case, because it's an async event, we allow the plugin to perform functionality, call a callback, and then we continue. So here's a super, super basic plugin. You saw it once before. Of course, I like writing them as classes because it makes more sense to me. But we have a constructor, and then the only rule is that it has to have an apply function or a method or property on the prototype chain. And that way, we gain access when we register this plugin to the compiler itself, and then we are going to listen to the event and do something. So in the same way, my beautifully drawn slides, one, we apply and we gain access to the compiler. Then, when Webpack runs or when something that uses the system runs, it then triggers these hooks. So you might be like, Sean, why do you keep saying tappable instance? Or you might hear it a few times. All that means is a class or an object that extends tappable, or really something that you can plug into. So another diagram might be, this is very specific to Webpack, is that to access the compilation, which is another instance, we have to plug into or tap into the compiler first. And then, as you can see here, the compilation also has lots of different plugins that are executing different functionality. So we're going to talk about what are these 7 tappable instances. So compiler is the first one. It's kind of the, I say central dispatch. It's kind of like start and stop. It really delegates the top-level events that are happening when Webpack runs or finishes. And it's exposed via the Node API. And then we have the dependency graph, so the compilation. There we go. I kind of call it, it's like the brain. Everything that's super juicy about what Webpack does happens inside of the compilation. It's created by the compiler, and it contains our dependency graph traversal algorithm. That's such a mouthful. Basically, how we collect and create the dependency graph. And then we have the resolver. So who here has ever used or understands what a resolver is? Okay. So don't get scared by the name. All a resolver does is it resolves. It finds things. It just finishes. So let's say, for example, when you use a shorthand syntax for a path in Node, the Node's native resolver gives you the absolute path and verifies it exists. So in the same way here with Webpack, our module factory might be given this partial path to, let's say, an entry point or an import statement. And then the resolver just says, OK, let me go find out and make sure it works or it exists. Then when it's done, it actually will return a lot of extra information, like what folder was this file in? What's the absolute path? What was the raw request, etc. And as you can see here, it is tappable, and so there's already, Tobias basically came up with almost every single plugin that you could think of that you would need to make this as configurable as possible. Okay, so now we have module factories. So who here, so I know the Angular users out there who is like, I know what a factory is. People know what a factory is. All it does is return objects or something. And so in this case, we have a module factory that takes a resolved request, and then it collects the source for that file now that we know it exists and we know where it is, and it creates a module object out of it. Wow, look, it's so beautiful. And it goes through the factory there. And then we have the parser. So who has ever written a parser? Who knows what an AST is? Who's written a Babel plugin? Okay, so you all in some way have been exposed to an AST. So a parser parses. It will convert raw source code into a tree called an AST that can be easily traversed. And so what Webpack does is we parse the file, and then we extract all of the dependency statements, so requires, imports, etc. There we go. And then we create these things called dependencies or dependency objects. So if I was to diagram this, we take this module object that we've received, and we pass it through our little glasses that are parsing. And then we add dependencies to our module. And then we have the template. So who here has used a template before in UI, in your UI code? We all know what the purpose of a template is. It's for binding data to your view. Well, in this case, for Webpack, we're just binding data to the source code or the code that we're going to generate, or the modules in this case. You can kind of think of it like the configuration is our props, the dependency graph is our state, and our template is like the JSX. So it creates code that you see in your bundles. So if I was going to diagram this, if we look here, we have a template for every single kind of abstraction. So a chunk, which is just a container to keep reference to our modules in our graph, that is going to have a template. Our module has a template, and each flavor of these dependencies are going to have templates. I just use like handlebars to describe this. And then when we call render, out pops what you see in a Webpack, like in a bundled file. So let's recap what we've just learned. So if we started out with the entry, we're going to read the entry point that we got from the entry property, and it's going to go through and verify that it exists. So we're going to the resolver. And then once we've verified, we're going to get this normal module object, and Webpack is going to pass that to the parser. And if it's not JavaScript, that's when we pass loaders against it. And if it is JavaScript, we're going to collect dependencies and attach them to that module. But we don't know if those dependencies actually exist, and so we have to resolve them, and this entire cycle repeats until the graph is complete. Tobias, check my work. Does that sound accurate?
Sounds good.
So yes, that is exact. So now, how does this dependency graph get into the browser? So I wrote this comic. I drew this comic. Hi, I'm a module. I can't wait to work in the browser. Whoa, cool your jets. We need to get you into shape first. You need to jump in this thing we call a chunk, and we need to keep track of you because we're going to throw a crap ton of plugins at you. We don't want to lose track. All right, almost there, but we have a problem. Those require statements have to go. But the parser gave us some special instructions called templates and a factory so that we can replace them. Wow, I'm finally ready for Browserland. Look at this. Thank you. So you just learned how Webpack entirely works under the hood. Entirely. Entirely. So how do we feel comfortable about this so far? Yes, kind of? Okay. Excellent. That's good. That's more hands than I've seen before. Excellent. So now that I've kind of talked about everything that, is to know in terms of our architecture, I want to give Tobias the opportunity now to talk about what are we going to do for Webpack 4. So you understand how it works. You understand the concepts. So what are we going to do to make, how are we going to make this even more powerful?
Yeah, thanks.
Yeah, thank you.
Okay, you've seen the plugin system from John.
Yep.
But we're changing it because it's a bit bad that we always use strings in there and long method names, and it's just weird. And the biggest problem is it's unperformant to use strings, and it's not monomorphic. And so we are changing it to a new syntax. But it's transparent for the user. If you don't only use Webpack, you don't see it.
Yes.
But the new syntax is like this, and all monomorphic hooks and better performance.
And people can get typings while they... Yeah, you can even get type analysis while you create a plugin.
Yeah, if you create a plugin, you can see all the plugin hooks we have with typings that somebody will create. Hopefully. Yep. Hopefully.
It may not be us. I spent a little bit of time on the plane, but it was kind of difficult. So yeah.
Okay. Okay, we're editing a new feature, which basically currently we have the runtime always in the first chunk, and to load the other chunks, you have to have the runtime in the browser.
Yep.
And this is a bit uncool because you can't use async script tags because the order is important. You have to load the runtime first and then the splitted chunks. And so we're changing this to a pattern which is also used by some other things, which is we create an array and push to the array, so it's order independent, and you can use async script tags, which have a lot of benefits.
Yes.
An example, if you have the main or the vendor chunk cached or the comments chunk cached and other chunks not, then it can be evaluated before the other chunks, and it's not don't have to wait for the chunks defined before in the HTML.
I think a good example is like I've seen people try and do multiple commons chunks, but that can create chunk dependencies, and sometimes the order can be not as expected. But this solves that problem.
Yeah.
Okay.
Yeah. So we're also adding a very big change is that we allow other module types than JavaScript. So we want to have native support for WebAssembly example, and we also add with the same pattern native support for CSS, because currently CSS is a bit of a hack with the extract text plugin.
Extremely
hacky.
hacky.
Really big hack. So you get native CSS support, which means also that you get a separate CSS file by default and all the fancy stuff in separate CSS files, and you no longer have injected the CSS code into the JavaScript bundle, and you don't have to double parse it, so that's better. And WebAssembly is always cool.
So you'd say, so now that you kind of understand how Webpack works under the hood, we can kind of explain what this means. So when you saw our template, our module factories, our runtime, our parser, it's all centric around JavaScript, and that's it. And so for the work that we're going to have to do is put an abstraction layer. It's okay, you can go all the way back, our friend. Yeah, like even the templates, it doesn't matter. But essentially what this will do, we now can have the opportunity to put an abstraction layer on it and make X as a first-class citizen. And so you might see new Wasm templates, Wasm runtimes, a Wasm resolver, a Wasm parser. And so we want to be able to provide and create the same opportunities like code splitting, scope hoisting, and everything that's possible for Wasm and JavaScript and CSS or even HTML modules in the future.
In the future.
Yep.
We start with this 3 module types and may extend it to HTML.
Yep.
Okay. Here's an example for the Wasm stuff, because it's very cool. You can just synchronously import a Wasm module, and Webpack take care of the asynchronous compiling and loading of the Wasm part. It basically hoists it to the next chunk loading. So if you load a chunk which contains Wasm modules, it will load the chunk in parallel to compiling and loading the Wasm stuff in it.
Yeah. So why, and I always ask, why can't we just use Wasm, Rust, C++, just like a JavaScript module? And so that was our goal. And of course, we were awarded a grant for $125,000 by Mozilla to implement this work. So we're super excited to get this out to you guys. And we're working with teams like V8, Chakra Core, to be able to ensure that these LLVM tool chains are nice and fast and work really well with Webpack to allow you to do things like this.
But it's a long way.
Yes.
We probably take a year to have good support for native languages. The compiler infrastructure need to be adjusted, and loaders for Rust and C++. Mm-hmm. So it's take a long way, but Webpack 4 will start with basic support for Wasm modules.
Yep.
So we always seen this in the main stage.
Igor slipped it on us.
So you basically get better optimization for big libraries, which contains many modules like Lodash, or here's example with X.js or so. The problem with this pattern, you import some function from Lodash, but the ECMAScript spec says every side effect in this Lodash library must be executed. So because JavaScript is a bit wonky, it's not the Amplify or Webpack isn't sure about is this a side effect or is it just a prototype where you add a method to it, and it's not used. So with this pattern, you currently get big bundles because many side effects are executed. And so Webpack will introduce a new package level flag, which is called side effects false. So you basically opt in to say Webpack, yeah, my modules don't have side effects. So if you import them and you don't use the exports, you can omit them. So and basically Webpack does this. If you write something like that, it follows the re-exports and basically rewrites it to include only the module which contains the flatten function.
Mm-hmm. So that way, we should see out of the box. So we're working with package authors like Lodash, and I'm working with teams who have open source projects like React Fabric UI at Microsoft, as well as RxJS and the Angular team, to ensure that this can be something that will be available and possible immediately when we release Webpack 4, and so you can use it. We want to ensure that there are huge wins out of the box for you just by updating to Webpack 4. And I believe there's also probably going to be a whitelist property too, right?
Yeah, it's planned. Currently, it's only supported to have a flag for the whole package, but it's planned to have a module specifier or something like.
Nice.
Only this files, but not. I guess we added in a minor version.
Sure. And JD Dalton is on my team at Microsoft, and so he's super excited to see this too.
Yeah. Okay. Yes, we also changed a bit in the process for Webpack release. For Webpack 3, we released a release candidate, and a week after that, released the release. And this was a bit unfortunate because the authors complained about it's too fast. No, we can't adjust.
Can't keep up.
Can't fix our code to this fast. And so we give them more time, a month between release candidate and release. So maybe with this release, most plugins and loaders are compatible with the new stuff.
Yeah, absolutely. We listen to, anytime that we try and ship fast, we end up hearing from our package authors or dependent authors, and so we decide, okay, we'll find out from the ecosystem how we want to release a breaking change, and so we typically say 2 to 3 months, and then we'll give module authors a chance by having an RC for a month so that they can make sure they can catch up, report bugs, etc. So you should see a benefit for the ecosystem in that when you upgrade to Webpack 4, even though there may not be that many breaking changes, that it, whatever dependency, or if you're writing a package or a plugin for it, that you can have time to test it before we release. So, yes. Is that the last slide? I can't remember.
I guess so.
Excellent.
That's
beautiful. That's it. So, yes. If you guys have any questions, of course, we can't do Q&A now, but feel free to stop by either of us and say hi, or anything. Literally, Webpack is created by you. So every person here who came to support us at this stage, we thank you so much. And so thank you, guys.
You have the chance to give some questions.
Oh, we do have questions. Awesome.
One question, yes.
Oh, okay. So could you please advise how to so I guess if you do have some questions, you can ask them. So how do you dynamically include chunks file name if rendering a page via JSX template on server side? Do you want to take that one?
Yeah, you basically need to take the JSON stats file. There are some plugins to write it to a file, Webpack stats plugin or so, or many plugins. And this file contains all the information about how the structure of the Webpack bundle is, and also the chunks file names. There's a mapping with name to file name, and to just read this file, and you get this chunk file name.
So hopefully that answers your question. When's Webpack 4 ready? So we have Tobias always says when it's done, but I think so. We still have some things that we need to finish, but we never give a solid timeline. We do promise that we won't release something within 2 or 3 months of the previous major release. But if you want to try it out now, that gives you an opportunity to really report bugs and help us feel good about shipping the RC faster. So if you check out the project on GitHub, it's under the next branch right now. And so I tested it, on the plane and before, like the week before, and in most of the basic cases, it was working pretty well. So yes.
We probably release some beta versions before, and then a release candidate, so you get the feeling when it's near to the release.
Would you use Webpack as a static site generator? Would you?
I would.
I probably would. Yeah. Why not?
There are some site generators which use Webpack. I don't know the names, but
Gatsby is a good one.
4 or 5.
Phenomic, Gatsby.
Yeah.
I know Nux.js, but that kind of isn't truly static. But yeah. Can a CSS file be the entry file?
It can be, but it's not recommended. You shouldn't put the you shouldn't separate the styling from the JavaScript stuff. You should have an entry point to your application, which is a dependency graph of all your dependency, JavaScript and styling. So many people do this, have an entry for JavaScript and have an entry for styling, but it's kind of an old pattern which done with runners and task runners. But in Webpack, the idea is to have a complete dependency graph of all styling and script stuff.
Yep. Any early advance for Webpack 5? Well, I mean, we try not to think about the next version until we've really been comfortable about shipping what we've set out to for Webpack 4. So, I mean, so most of the time, up until we started hearing feedback like, guys, don't ship majors so fast, we get scared. And so we're like, okay. So what we decide is that we'll wait 2 to 3 months, and what we'll do is any breaking changes that provide performance or any other features, we'll hoist into, we'll just kind of keep it suspended in our GitHub. And then those will land into Webpack, the next major version, whatever it is.
It's probably going to be Wasm.
Yes, Wasm, yeah. Assembly, support, very likely that you'll see that in Webpack 5. Why is module concatenation disabled by default?
Yeah, the plugin was an experiment, and it's basically in experimental status, and we added it in Webpack 3 anything. So we can't. It would be a breaking change to enable it by default in a major version, but I'm planning maybe to do some refactoring with optimization and separation between production and development stuff in Webpack 4. Maybe there's a production optimization development flag which you can set, and then you get all the good stuff for production and all the good stuff for development. Yeah,
and when you think about it, it is a production feature only. So don't use it on your dev server. Don't use it with HMR. It's broken with HMR, I'm pretty sure.
And it's not broken.
Yeah.
It's behaving a bit different, but it's kind of working.
I mean, the point is that we can't assume that you have a production or development environment. We can't assume anything. That's what makes Webpack so powerful to use, is because you have the ability to make it work for your stack. So if we were to put that on by default, everybody's builds would be inherently slower. At the cost, for us, it's easier for us to have a feature that's available free to opt in and not make any assumptions. What best practices should we follow for the best code minification? What plugins, how to import, etc.? That's a good question.
This was Igor's talks, basically.
Yep.
Enable module concatenation, enable use Babel with modules false, use code splitting, and Uglify or Closure compiler. Yeah.
Babel preset env is also really good advice if you are using Babel, because it's going to look and see it's basically auto prefixer for your JavaScript. And so you pass the browsers that you support. If you only support one browser, then there may be a likely chance that you don't have to minify, transpile all of the different syntaxes that you're using. So should an external flag dependency be a peer dependency or a normal one? So in externals, if they're doing a library package.
Webpack doesn't care about this. Yeah, it depends. If you, in general, a peer dependency is something your library. In example, if you are a plugin or something like that for other project, then it's a peer dependency because you want to give the user the opportunity to choose the library, and you are the plugin for the library, or you can specify which range is possible. If you're a dependency, then you basically always get the latest version which is in your range.
Yeah. Is it good to use Webpack for Node and Express? My opinion, yes, absolutely. One of the things that we haven't gotten enough intel on is when you bundle a Node app, it's sometimes faster because the module resolution in Node can be a little slow.
So slow.
Yeah, and so when you bundle a Node app, it's kind of faster. And you instantly can use ESM syntax. So no .mjs, no any of this crazy stuff. You can literally just bundle a Node app. And anybody here use hot module replacement for their APIs? Or yeah, it is really nice feature. Super nice. You can literally update your code without having to close out your server, restart it, check the API to see if it works. It's just instant when you update your code. So yeah. Can you give us some Webpack t-shirts? I have a huge... So I do have a bunch, but they're extra large and XXL. So, but I do have a bunch back in the hotel room. So throughout the day, you can probably find me and we can get those for you.
Some too.
Yeah. Is there any plan to start using TypeScript or Flow for Webpack? It makes easier for more people to contribute. So this part is your opinion only. That's your opinion only, and so you can't really speak for everybody who's a contributor. But is there a plan? So it's really hard. There's a lot of different reasons that we don't want to. I'll let Tobias speak to his. I think one, it is a complete, we'd have to completely change our architecture, and we have never, ever in Webpack had to have a build step for our library. And so there's a lot of benefits, like being able to instantly link or allow people to check out from GitHub and not have to do any build step or anything like that, or shipping a dist. So, and I know you have opinions about the code style that gets transpiled and things.
Yeah, basically, if you write the code directly, you basically see what the performance is, and if you have a transpilation step, sometimes you don't see, oh, this is very expensive to use for off loop, which is transpiled to a complex pattern, or you can generate async functions or something like that. It's always a performance. Could be performance problems, you don't see it obviously, and we don't want to choose one flow or TypeScript.
Yeah, it's kind of that's kind of a controversial decision for us too. We believe that both systems are great, but we also don't want to make an opinion on them and cause an issue in our ecosystem. We care more about that than it comes to the structure and typings, and really once we have this new plugin system and we have typings generated for it, you're going to see a lot, especially through VS Code, a considerable amount of type support and IntelliSense while contributing in our project. So it should be a much more elevated experience than what it used to be. How much work will be required to update from Webpack 3 to 4 in existing project? Not too bad.
So far, there are no backend changes for the user. It's only for plugins, internal changes, and so if all the plugins and loaders you use are upgraded to the new Webpack 4, then it should basically just replace dependencies. And I guess currently there's no backend change in the configuration. Maybe we add some this optimization.
We'll find something, I'm sure.
Yeah, probably there's always sneaking changes you don't see.
There is, yeah.
But we have for 2 to 3 we have an upgrade guide, and we continue this with an upgrade guide for the user, which contains all the changes you need with code examples and so.
Yep. Oh, this is a fun one. DLL plugin versus Commons chunk plugin. Would you recommend? We picked this one, by the way, in case you're curious. Would you recommend for code splitting in Webpack 4? It feels like 3 questions. I'm not sure. So, I mean, both of them do completely separate things. So, DLL plugin. If you understand how external works, it's basically telling Webpack, don't try and resolve this file just know that when this code is actually in the runtime or in the browser, that this, whatever is set as your external, will be available. And so a DLL plugin just creates a bundle of these externals so that you can link together with another build.
Yeah, I guess if you do a vendor chunk, they basically do the same thing, but they have different benefits and disadvantages. And the DLL plugin is faster. You have a separate compilation, but you don't get tree shaking or scope hoisting in the DLL bundle. So, but with the common chunk plugin, you basically, the common chunk only contains the exports and modules you really use in your application. So it's tree shaken, it's scope hoisted, and so it's smaller, for us faster. It's basically
it's kind of the trade-off. So like I always tell people use DLL plugin in development mode because you're avoiding work of bundling time. So like your builds will be faster, but don't use it in production. You can, but those are the trade-offs that he just gave an example for. What are the best practices for using Webpack for large code bases? How do you improve build time? So that's one of the things we mentioned. So DLL plugin is a great example. We actually, so like, we have an entire like page that I think you even authored it yourself. So if you go to webpack.js.org/guides, you're going to see a build time guide, and Tobias authored it. This is one of the things. Take a look at your resolve property. Like now understanding how resolvers work, you essentially add a lot of extra build time by having really eloquent or complex resolve properties. I'm sure you could give advice to.
Yeah, the expensive one is loaders and resolving. So you can optimize the resolving with less extensions, less module directories. And the loader you can optimize with, there's a cache loader and a thread loader. Or Babel has a cache directory flag which caches the results. And basically caching is important on the loader side. And yeah.
And could you explain the difference between loader? We just told you the difference. Who didn't know that? No, that's okay. So I'll try and simplify it. What's the difference between a loader and a plug? Yeah, we can toss that. If you're still not comfortable, come find me and I'll spend as much time explaining how it works. Why don't we do this one? I like this one. Can we choose, or do we have to do the thumbs up? I want to talk about rollup. Okay, yeah. What do you think is great about rollup? So for me, I love it because it's focused. When you have constraints, you can focus on doing something really well. And so in this case, bundling a library is great using rollup. You can give your comments.
Yeah, it's rollup doesn't include a runtime into the bundle. It just scope hoists all the modules, and if it works with scope hoisting, it's great. And for most libraries, you can use it because you have control over the code, and then it's super minimum and readable output files. And Webpack is more about optimized and non-readable output files, and includes the runtime because the common JS stuff and all the other non-ECMAScript module stuff. So it's basically Webpack have to fulfill a broader range of dependencies and weird formats, and so it's less optimized than a rollup bundle.
Yeah, and like I said, like high level, like when you can focus on something constrained, you can do it really well. And so rollup is really good for bundling libraries, and we always recommend it. Thanks for Webpack. Can you talk about the contributor community? Thank you for using it. I mean, we would be nothing without you. You are the contributor community. Something that we like to say is like, it was a tweet from somebody who said like, stop thinking that you're just buying our product, but you're another member of our community, and that's what we think. And so thank you. I would say our contributor community has exploded in the past like 3 months. We've had people from all over the world. Who has contributed to Webpack here? Like we even have people here today. Thank you so much. Like we would not be where we are today. Yeah, let's give them a round of applause. Like, thank you. We would be nothing without you. And like we also have guides and things on how to contribute different ways. You can check out our Medium publication under Contributors Guide. And we have I've written 2 blog posts, and I should get the other ones out, but on how to contribute and what things to look for. Because to us, it's you take the things that you love to do, you take what you're good at and how you bring value, and then that's your purpose for our project. And so we want you to work on things that you love. It doesn't have to be code. It can be documentation. It can be tech writing. It could be focusing just on error messages. If you love working on error messages, we want you to do it. It doesn't matter. You could have 0 years of experience. You could have 20 years of experience. You could be a C# developer who wrote construction CT machines for a living until he started doing open source full time. It doesn't matter. So please, 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 if you're passionate about Webpack or you want to be involved, let us know. Will Webpack be open source always?
Sure.
Yes.
Always. We are a part of the JS Foundation, and the terms with the JS Foundation make sure that Webpack will always be open source. So it's
always.
It's not possible for us to make it closed source.
Yep, not even possible. How much time are we still have time for questions? Wow. Okay. Will Angular CLI work instantly with Webpack 4? Ask the CLI team. I know I'm on it, but I haven't been as involved. Likely, yes, it should. Will Webpack 4 support Emscripten-generated Wasm modules out of the box?
Not sure yet.
Like, I think they're talking about a Wasm library target.
What?
Like a Wasm lib target? Or is it talking about like just a pure Wasm module?
I guess it's about the difference between Wasm modules and Wasm modules for Emscripten, because Emscripten does some wrapper with the JavaScript, and basically it does a full linking step with a Wasm linking step, and
oh yeah, okay,
puts the whole thing in Emscripten, and we are more about separating each compilation, each C++ file into a Wasm module and make the dependency graph in Wasm, and Emscripten basically gives a big chunk of Wasm code which is generated by the whole C++ code base.
So when CSS becomes a first-class citizen in Webpack 4, will Webpack dev server hot reload CSS files directly instead of a blob URL? What do you think, Case? Maybe? Yes? So Case is actually also a maintainer of Webpack and works on Webpack dev server, so I pulled him up. Yeah. You can make it a yes or no answer, or like maybe, it doesn't matter.
Yeah, so when CSS becomes a first-class citizen in Webpack 4, will Webpack dev server not reload CSS files directly?
Could we? Is it possible?
Yeah, we do.
Well, I think we could.
Guess, yeah.
I think that'd be good.
Yeah.
I like it. Yes. Yes is your answer.
Yes.
I'm sorry for pulling you up on the spot, but I just wanted you to be up here.
It's a bit unfair because it's not technically not a Webpack dev server question, because the reloading runs over the hot module replacement stuff, and yeah, it's part of the Webpack core, so it's not a Webpack dev server question.
Yes, it's not really a dev server question.
But most people think so because
yeah,
you never use it outside it. So.
Yes, exactly. So using resolver for paths, IDE doesn't see them. Could we expect a plugin for it? Yeah, you just learned how to make a plugin. Okay. So you can reach out to us if you want advice or ideas or how to. Or maybe if you're a VS Code user like myself, we would love a resolver language service. How cool would that be? Do resolve aliases slow down the build? Is there an optimal amount to use and be fine? There isn't. I mean, don't use as many, but I would say, what do you think the least slow resolve configuration is? Alias?
Yeah,
modules?
Alias only does some string compare, and then it's basically ready. It doesn't introduce extra I/O to the build, so that's the most performant option you can use. But I guess there was a bug report about somebody made 10,000 alias configurations, and it's causing a Stack Overflow or so.
Oh my gosh. Yeah, so don't do that. That's not even practical. Okay, so is Webpack 4 going to support basic stuff for WebAssembly, or are you going to be adding advanced extra features as well?
Yeah, we want to add extra features, but Webpack 4 focus on the basic features because we want to get something out, this basic Wasm support, to see how the crowd reacts and
yeah, like how it works. Like, does it work, and how well does it work? Is it successful? So Thank you guys for all that was some really cool questions. That's a really cool like service. So awesome. Thank you guys so much. You can find us afterwards. Thank you. Thank you.